Hello, everyone. We're all set for our next presentation. Whoops. No trip. So our next up is relying party security considerations for multi-device credentials. Again, fortunately to remind people, short presentation time. We will do our best to take time for questions. John's easily identifiable, as you'll see in a moment. Feel free to approach him afterwards. Use your imagination. Feel free to reach out to him in the hallway at lunch and back at his hotel room. Anyway, so who we have right now is John Bradley from Yubico. Welcome, John, and thank you.
Thanks. Okay, it's on. So I want to, Tim just kind of gave you the passkey parade, and I'm not here to rain on the parade, maybe just a little bit of light drizzle. So I want to talk a bit about some of the things that relying parties are going to have to think about as passkeys get rolled out. So passkey, what is it? So the first thing I did was put an uppercase P to annoy Tim. Well, yes. I mean, if I can't annoy Fido, who can I annoy? Yes, there's a long list. So as Tim pointed out, it's a Fido credential used for passwordless login. I used fewer words than he did, but we all get the basic idea. So passkeys support discoverability of the credential by the relying party so that you don't need a username prompt. So what passkeys aren't is the thing that most people are used to with Fido, which is you go to Google, you put in your username, you enter your password, and then it prompts you, you touch the button and log in. So passkeys are not the things that are not the server-side credentials that people have become used to using with Fido. These are sort of a new pattern. If you've used your Fido credentials to log into your Microsoft account, then you've used a passkey. Microsoft rolled out passkeys a long time ago on their own user space. So the next thing that is different is that those original passkeys or the original Fido credentials, when you logged in, put your username password in, RPs didn't want the user to be prompted with a PIN to unlock their Fido credential. So we made in WebAuthn, we make user verification optional, and I'll dig into that a bit later. The third thing is that the new credentials, the new passkeys without single device, and I don't actually like the single device term because on a roaming authenticator, you can use it with multiple devices, but the credential itself is for a single authenticator device, which means that you can use multiple devices with the single device. So we should just never, ever talk about that to consumers. They're all passkeys in my mind. So password managers sync passwords between computers. We're all fairly familiar with that. And the default behavior of passkeys is that they're synced. So the other new thing that the single device passkeys didn't have is that users can share passkey credentials with others. You can share the passkey for your Netflix or your bank account with your spouse or cousin or guy down the street, just like a password. Passkeys are a replacement for passwords. It's pretty straightforward. We shouldn't try and overthink it. Passkeys replace passwords. Any place that people have been taking a password, they should now take a passkey because it is better than a password. So let's dig into some of this. Discoverable credentials. So it's an improved UX. Again, Microsoft has supported it for a long time. If you have multiple accounts at the relying party, multiple things will pop up in the dialogue. One of the things that stopped this from catching on 3 years ago when it first came out was that one of the mobile operating systems that supported Fido never supported discoverable credentials. That shall go unnamed, Google. So because you couldn't use your discoverable credential from Android to get into your Microsoft account. It never really caught on, especially enterprises. Yeah, it works every place except for, well, iOS and Android and OS X or any of the other places that you want to use. So worked perfectly fine from Windows with Windows Hello, but not other places, which is a real problem for deployment of the new better UX. The other thing that's new is, which isn't necessarily directly related to passkeys, is the autofill UI that Tim was showing you. Makes the login experience much more integrated with things that people are used to. So all in all, discoverable credentials, passkey, more platforms support discoverable credentials, everybody wins, whether it's credentials from your ancient Windows 10 computer, your YubiKey, etc. All work in this, all good. No downside. User verification. Perhaps Tim and I have a slightly different understanding. So it's, probably self-evidently, it's required, if you intend to do multi-factor authentication, doing some sort of user verification on the device, which is the thing people have, would be the second factor that makes it multi-factor. So most RPs that are currently doing FIDO don't ask for user verification. They send user verification discouraged because it's really annoying. You've probably found some sites where you enter your username, enter your password, enter your PIN, touch the button, which is kind of three-factor authentication. The RPs never actually check that the multi-factor was done from the authenticator. So they're just, because they didn't add discouraged, they just left it at the default. Users are annoyed. So it's optional. Most RPs either send discouraged currently or don't say anything at all, which makes it optional. So RPs, currently don't ask for it, currently don't check it. If you're actually intending to do multi-factor authentication, you should do that. So an example, not all operating systems actually have biometrics. So you might have a desktop Mac that you didn't opt for the extra biometric keyboard. As an example, older MacBooks, the password managers have similar issue. So on Mac OS, if you don't have a biometric device, it will prompt you, if the RP says password required, it's going to come up and say, enter your login password. And then the user is prompted for their login password, which isn't a particularly good experience. So Apple's developer documentation currently says, ask for user verification preferred, so that on devices, say Dashlane, Apple devices without it, and other authenticators will have similar issues. When the user gets prompted, it'll just skip this, and so the RP will get back a cryptogram without the user verification flag set. So as an RP, if you want a good user experience, probably setting user verification to preferred. Whether you set it to required or preferred, you should always check the user verification status in the cryptogram, because somebody can always have some JavaScript that just changes the request. So just because you ask for user verification doesn't mean you get it. There could be a man in the middle, or it could be a device that just doesn't support user verification. So if it's important to you, you need to step up with either a push notification app or some other method. If you actually need a fresh user verification, has the user proven themselves to this device recently? Most cases where a password is required, you probably actually don't need to step the user up if you think about it. The users unlock their device, it's more or less equivalent to someone logging in with a password. So if you were only doing single-factor authentication, you probably should just take the passkey. If you had higher expectations, then you may want to step up. If you know that you have a requirement for multi-factor authentication, then you have the option of setting user verification required. So the user will get the ugly user interface, but you don't need to step them up using another method. So passkey backup, some people call it sync. In CTAP, we call it backup eligible credentials. So the good thing about backup eligible credentials is that there are flags. First, you can tell whether or not the authenticator supports it. You ask for an attestation. You can look up in the metadata whether or not it's an authenticator that's giving you multi-device credentials. There is a small issue with the attestations, which we'll get to later. Authenticators that are backing up are supposed to, if they're certified, they're going to be setting the backup eligible flag, which means that this credential could be backed up to the cloud or copied to another device, and another flag that says this credential has been backed up. So if you're a consumer site and you only have the requirements of a password, if you see that it's backup eligible and it has been backed up, then it gives you as an RP the opportunity to take away, remove the password or other insecure authentication mechanisms once you know the user has some way of recovering and getting back, doing account recovery through Apple, through Google, through Microsoft, or Dashlane, or whoever that third-party sync provider is. So the idea behind these flags is that it allows the RP to remove the insecure methods of authentication. So you want to probably look at those. So some of the things that you have to consider is that if there's no attestation, and at the moment no passkey, no multi-device passkey actually supports attestation on the primary credential, which is kind of how you can tell if it's a multi-device passkey. So if you get a registration, when the user's registering, if there's no attestation, you pretty much have to assume that you don't know what the authenticator is and probably should treat it as if it was a multi-device credential for your security concerns. So also, the credentials that are backed up will have different security properties depending upon the provider. Now, that will vary between providers. In general, you have to do more to recover your iCloud keychain with Apple or your synced information with Google than just logging into the account. You need to, in the Apple case at least, provide your iCloud password and a PIN from your phone. So different providers are going to have different amounts of security that RPs should be aware that not all sync fabrics are necessarily the same. But at the end of the day, you know, if you allow an email reset, it's easier for an attacker to get into that person's iCloud, Apple or Google email account and do a password reset than it would be to compromise the user's passkeys. So we can all say, oh, well, you know, they could do this, but you're probably doing things and have backdoors into your account system as an RP that are lower security. So a passkey without anything else is more secure than the email password that would, emailing a password that's going to allow recovering the account. So, you know, you have to think about it, but you should really think about your security requirements and do you have backdoors that are less secure than what the passkey is giving you. Now, some people will have regulatory compliance issues that you may have to, as an enterprise, you may have to have more control of your credential life cycle. You know, is backing up someone's credential to their personal account at Apple actually going to make your auditors happy? Now, potentially, if you only have single-factor authentication, they put it in, they save it to Safari, they're already saving their password to Apple, but you may have a second-factor authentication enabled with push notification, et cetera, so it's not completely dependent on Apple. You have to figure out what your actual requirements are. So let's look a bit at sharing. And I'm not sure, is there a timer here someplace that tells me how long I have? 9 minutes left. I have 9 minutes left. I'm going to talk faster. So depending upon the platform, at least Apple at the moment allows airdropping. So you can go to your password menu on your iPhone, find the credential, all of your saved passwords and passkeys are in that dialog. You can click on the top, the share information. Anybody that you have in your contact book and is close by will turn up, so you can airdrop your passkey credential to your spouse, as an example. When that person has that passkey, they can share it with anybody else, and the username information, the entire account information is copied. So that user that you've shared it with, that's now tied to their biometric on their device, so they can unlock it and reshare it completely independent of the person who originally shared it. I had someone ask me earlier, well, what happens when I delete this credential from my account? Is my spouse no longer going to be able to get in? No, they'll actually still be able to get in. The user needs to go into Netflix or the bank and remove the credential there to be able to stop anyone that they've shared the credential with from being able to get into their account. So again, users share passwords now. Some financial institutions do fingerprinting so that they know, yes, it's somebody coming in from a new device. I'm going to do some sort of step up. You know, what was the name of your elementary school, or something clever to let somebody come in from a new device. You may want to do something like that with a passkey. Now, Tim mentioned the device public key extension. So you should really think of this more as a cryptographic fingerprint for the device. It isn't really a separate credential. It doesn't necessarily add a whole bunch of magic security. It is a device fingerprint. It's a device fingerprint that the platform vendors have said they're not going to block. If you're in the financial industry, you probably spend a bunch of time complaining about the limitations of fingerprinting and how the platforms are reducing your ability to do fingerprinting. And just a couple of weeks ago, I was at a presentation from a university about how you can man-in-the-middle fingerprints from devices, and they're not really very secure. You know, they're mostly theater these days, that people, the reverse proxies that that steal people's credentials also steal fingerprints and can exactly reproduce them for financial institutions. So this is a cryptographic fingerprint that is harder to be stolen, but one of the reasons why not everyone implements it is that some of the platform providers don't want users to be annoyed when they move from one device to another. They don't want the user to be reprompted. They want them to be able to seamlessly log in. So there's a resistance to everyone supporting device public keys because that's going to cause user friction. And it's better to make it simple, fast, and less annoying than potentially have the cryptographic fingerprint. You can still, even if the device doesn't, the person's coming in from doesn't support DPK, you can still do a traditional fingerprint. but a DPK is better than a fingerprint, but you should only consider it a fingerprint. The other thing that we didn't really talk about in Tim's presentation is that the device public key extension also has an optional attestation. So in a lot of cases, especially if you're an enterprise, you care about, well, how is the key secured? What kind of device is it, et cetera. So the DPK attestation tells you that that device public key is coming from a specific device. It's an iPhone. It's using a specific chip, what have you, using Face ID or fingerprint, et cetera. So you have an option of, when you get a new DPK, you have the option of looking at that, making some decision about how secure the device is, and either doing some sort of step up or allowing the person through without further annoying them. But the only way with a multi-device passkey, the only way to know what the person is logging in from is through this attestation on the device public key, because the whatever primary attestation you were getting is potentially for the sync fabric and not tied to an individual device. There are no, other than a test YubiKey that I have that produces DPK attestations to test browsers, there is no instance in the wild of DPK attestations. None of the platforms have currently released that. So people ought not to count on this in the near future. My advice is passkeys are better than passwords. If any place that you were taking a password, take a passkey now. But there's a bunch, as a relying party, there's a bunch of re-engineering you need to do to your back end to be able to store. So a person has a single FIDO credential, but they may have 6 devices. So you now have to re-engineer your database to store all 6 device public keys. When they log in, check, like a fingerprint, check against, is it an existing device? So there's a whole bunch of your existing FIDO backend isn't compatible with DPKs. It's going to take people a while to update to that. So in the interim, for better or worse, live with what passkeys give you. And down the road, some of this stuff will come to fruition, but for the most part, passkeys are better than passwords and generally move the ball forward. So do we have time for questions?
Probably one. So this one got one upvote, so we'll pick that one. To help RPs operate seamlessly with regulated enterprises, why can it not be mandated as a part of the specification all platform authenticators to support DPK, and then the issue with lack of passkey attestation goes away?
Because FIDO doesn't have the ability to do that. What we have said is that if you want to be FIDO certified, you need to support DPK and DPK attestation, but nothing makes a platform provider or any other security key provider actually get certified. For uncertified devices, FIDO has no control over which extensions they implement or how. And yes, the extensions are optional. We could say that they're required, but it wouldn't actually get us anywhere.
All right. Thank you very much, John.